Good morning, everybody. This is John Scarborough. Today I wanted to talk about building trusses for your house or a barn, such as this shop that you see back in the back here. These are 4 stacked trusses that I have. This is a process that you can go through to build trusses if you're wanting to build a building. So if that's something you're interested in, then that's what we're going to talk about today. We're going to talk about kind of the processes of laying them out, making them quicker and easier to build, some of the things you might want to use, some of the different types of welding rods that you might want to use when you're going through the building, and a couple things you might want to think about, and then a few things for sure that's going to make your process quicker and easier and more likely to come out with really good positive results. As I will tell you right off the bat that if you don't get these pretty close to the same, you can see how a building would be, I mean, it might be up and down. Like if your trusses aren't exactly the same, or at least really close, then your building could be one way or the other. So it's definitely really important to get it all right. It's not that difficult. So throughout this video, I am going to teach you how to do that if that's something you're interested in. Closer to the end of the video, I'm going to share a little bit of a tip that I think is something that everyone should know that will really help prevent problems that you may have. I've seen a lot of people have these problems, and I'm going to try to share that tip to where hopefully keep you from having those issues. All right, guys, let's get right into it. But before I do, I want to say really quick, full disclaimer, I'm not telling you not to get an engineer. I'm not telling you how to do this. You know, you do your own research. This is for educational purposes only. This is me teaching you what I do to do it. With that being said, I have built several fully engineered buildings, and I have worked for several companies doing this. I've also done this for myself several times, and I've done it for customers as well, under the guidance of engineers and engineered buildings. So the knowledge is coming from that, but that doesn't mean that you don't need to do your own research. Every site's a little different and like that. So do your own research, guys. All right, right to the video, guys. First thing, you notice here that we're using pipe for our post. Okay, some people say never use pipe. Some people, they use pipe. Okay, obviously I'm using pipe. Okay, pipe for me is cheap, but I will say that this is very heavy wall pipe. It's 4.5 inch, and it's heavy wall pipe. A lot of times people use pipe and they're using something real thin, and it's just not going to bear the load. It's not handling that load. Okay, there are some pluses to pipe in my personal opinion, and we'll go over some of that here in just a minute. Not everything has to be built out of pipe. Obviously pipe is a little bit more difficult as far as your post goes. This building right here was built, this building behind that camper right there was built out of square tubing for the main frame, but it was built out of pipe on the lean-tos. And it's a good building material, and sometimes it can be a very affordable building material, but it's not necessarily the easiest. So for that, because of that, I'm not going to opt for pipe if I'm building a building for somebody else. Okay, so typically if I'm gonna bid a job, then I'm gonna bid it with I-beam and then I-beam pipe, I-beam post as well. And the reason is because of simplicity and speed. It's significantly faster and easier, and so it ends up saving the customer money. Even though even if they have pipe, I always encourage a customer to go with the I-beam because you're paying me to do it, and it's a little more complicated to do pipe. So it ends up being about the same, about a wash, or sometimes even I end up having to charge a little bit more. But when I'm doing it for myself, I can save myself money by using pipe. So let's kind of get into some of the meat and potatoes, some of the details here. If you look here, when I'm using pipe, if I get in here close, get my camera to focus well, you can see what I did. Now this is not welded yet, we're only tacked. You can see these are the welded ones. This is after we get it all welded. That's going to be similar to what it's going to look like. Okay, I did fail to clean my paint off on all the other ones. I remembered, and I forgot to clean my paint. But what you're going to want to do is cut you a piece of plate. So cut this straight, okay? And it's a lot easier to cut this with a saw or something like that, and it's a lot better because when you cut it with a torch, then you have to clean it, and like that. Even if you're really good, you still have to clean it. And the more gaps you can see, like this one right here, I got a little bit of a gap up here. The more of a gap you have, the more heat you create, and especially on pipe, but really on anything, that heat can cause stuff to draw and warp. And on pipe specifically, you get build up enough heat here, it can actually warp below this weld. So even if it doesn't warp here, it can warp below this weld and actually draw that leg in. That doesn't mean that that doesn't mean that you can't repair it or fix it. But what that does mean is that you may have a little trouble. You're just going to fight it more once you get it in there. So for me, it's a lot easier just to cut that perfectly square, take me a plate, add my plate to the top right there, cut this off. For me, this is a 412 pitch on this roof right here. So once I do all my math and check this ended up being a 72-degree angle. So I cut my pipe off at a 72-degree angle, and it's a flat angle. It's not a 72 pipe angle, obviously. It's 72 flat, and then that way I can just weld that right to that. But this one right here is pretty easy. You just cut this piece of plate out, you slide it down right here, tack it into place, and then you weld it all out. And that just makes it a lot easier. You got plenty weld surface, and you don't have to worry about trying to cut this out, notch this all right. You don't have to, it takes away a lot of variables. Plus, if you don't get that curve just right, like if you were trying to cut it out on this I-beam, and you cut the curve, if you don't get the curve exactly right, your angle may be off a little bit, okay? But by doing it like this, you ensure you're most likely to keep a good connection all the way across here, which is what's really, really important, okay? And then now you just put that in there and weld it up, and it's just a lot better connection. Secondly, I'll see a lot of people when they use pipe or even I-beam, they'll take this truss and they'll lay it right on top of their pipe. So this part right here would be moved all the way down, okay? Now, let me tell you why I don't like that. Because you're just welded to the very top of that piece of pipe, which means wind load or anything can bend this entire truss back and forth. You have nothing supporting that truss from bending one way or the other. Now, a lot of people do it, okay? But I personally do not like it. I like this. It's a little bit harder to do, but you get so much more surface, so much more weld, and there's so much more rigidity like that. So I really like that right there. As far as this plate goes, we'll climb on this side here. This plate, there's no need to weld 70-18 on all of this plate, okay? You're tying your pipe in right here, and you're tying in right here. So you definitely want this to have a good root pass, and you want this to have 70-18. And you want to put as much 70-18 as you can here, right in this area, because this is tying to your pipe. This is giving you structural strength. But everything you tie into here, like I would definitely wrap this with 70-18 and going ahead and come up here. And I've got, this is one right here. You can see how bad the gaps are. I just got out on my cut a little bit, but most of them turned out pretty decent. And we'll talk about how to get this, some simple ways to get this angle too, here in just a minute. But I would go ahead and wrap up to about the center for sure with some 70-18, and I would come up to here with 70-18. Everything else around here is not necessary to put in 70-18. You've already got so much surface weld, you've got enough strength that you're not necessarily, all you're doing is tying yourself to this plate. So once you tie yourself to this plate and you're no longer tying it to this I-beam, the plate is only tied on by this weld. So it's not necessary to over weld all of this right here, because no matter how much weld you put on this pipe to this plate is still only held on right here, okay? With that being said, I went ahead and went all the way around it with 70-18 simply because I already had the 70-18 in my hand, and it was simple and easy enough to just go ahead and put my vertical weld on real quick, knock that out, and then go ahead and just come around it, So there's no reason you can't. I'm just letting a lot of people know. A lot of people have trouble welding 70-18 vertical, and some people even have trouble welding 70-18 period. On that note, do not do this job, please don't do this job if you cannot weld with 7018. Okay, you can get away with only being able to weld 7018 flat, and you know, you can weld it uphill, but you're not great at it. Okay, you can get away with that as long as you know for sure that you're good with welding with 7018. But my personal opinion, this is my personal opinion, you take it for what it's worth, do not do this job unless you are good with 7018. Okay, and that includes uphill and everything else. Secondly, a lot of people will grind a bevel here. Okay, they'll go ahead and make a bevel. I don't know if you can see that gap right there. You can see daylight through there. They will make a bevel on here. Okay, I'm talking about a lot of people, and so this is a controversial subject right here. I don't personally like to make my bevel until after I set it up here. Now, it does make it hard to make a bevel in the corners. Okay, but I don't like to make the bevel yet, because sometimes you end up with a bad gap right there. And if you have a bevel and a gap, now you really are creating more heat than you need to. And the more heat you get, like we talked about earlier, the more likely you are to warp one way or the other and to have lots of different issues. Not only that, when something gets too hot, when a weld gets too hot, and I know my hand's covered in black, but once a weld gets too hot, it causes the weld to get brittle. So if you're going through and you're welding all this, and then all your base metal is getting hotter and hotter and hotter, and then you end up putting some of your 7018 welds on there, a 7018 weld is supposed to be flexible. That's the reason you use it. But then you're super smoking hot, and because you've already done so much, it's possible to get your weld brittle and then basically negate everything you were doing using your 7018. So my personal opinion, this is what I do, I like to get it up here first. Okay, now I will say real quick, if I'm doing an I-beam post, I will go ahead and bevel these edges, because there's no reason not to. Okay, that's a nice flat connection. Okay, so I'll go ahead and bevel those, but I'm not necessarily going to bevel this. Okay, if I did, then I would only bevel my corners maybe an inch in. Okay, but personally, I don't think it's necessary. I leave it unbeveled right here. If it's I-beam, I bevel both sides. And then once I get it all tacked up, I can tell I've already got a place right here that I can bead. So I'm going to grind all of this out. Okay, I won't be able to get all the way into that corner, but I'll get far enough that I'll be okay. I might not get a perfect root right there in that corner, but I'm going to get a good root connection in the majority of it. Like I said, guys, these are my opinions. This is how I build buildings based on what I've learned and what I've done. You need to look at your own codes, whether there are codes in your states and your towns and all like that. Do not take my opinions. These things are just to help you in building your buildings. Look up all of your codes and all of your laws in your local areas. Okay, so then I'm going to run my root. You make sure you put a root in there. Or if you cannot run a good root, then you need to get on that bottom side and make a pass on this bottom side. But the majority of people, the way we do it is we get our first truss. And you can see in this case, I actually had to level my first truss off. I had to use a transit and level the entire truss off. Typically, I'm working in an area where there's a concrete pad or something like that, and it's level enough, okay? When you're building your truss, it is important to get it level when you're laying it flat like this, but it doesn't necessarily have to be perfectly level. But when you're working with pipe, there's less forgiveness, okay? So if you can get it pulled one way or the other way, and it can be more difficult to get back right once you're standing that up. So especially if you're working with pipe, and if you're not working on a pad, you're working on a spot that's really out of level, like I'm 18 inches higher on that side than I am on this side, then you want to go ahead and level this first truss off. It's going to make life significantly easier. Okay, there's a lot to talk about here, so this is kind of just how this goes. Okay, you're going to want to grind this out, get that root in. If you cannot get that root in, make sure you weld on that other side. If you know that you're unable to weld that root, then stack these farther apart. I've got these 3 inches apart. I just put 2 2x4s in here. That's plenty far enough for me because I can root. I'm a professional welder. I can get a good root in there, and I know that I can get that solid weld on that other side and be just fine. So I know, and you can stick your hand underneath there and feel that root, and you know that you've penetrated all the way through, and then you can visually inspect it and make sure that it's a good solid tie-in. Most of the time, the way we do it, you can see we've got a double pass in here, and I'll show y'all some more. It's difficult to see in this lighting, but I'll show you some more in just a little bit. But we put a double pass of weld, so we got sufficient weld on this side and a bead on the bottom side. That is a very normal way of doing it. That's the way most people who build trusses do it. They typically put there's a bead on the other side, and then the majority of the weld is on this side. As long as you've got a good solid weld all the way up here and everywhere else, that's usually sufficient. Like I said, check your codes, but that's usually sufficient. Okay, so that's what we're going to do. We're going to grind that out. Right here, we won't have to grind that out. Okay, let's walk on down the line a little bit. When you're lining your trusses up, okay, one of the things you want to do, and it's maybe hard to see with this camera, but you want to stand right here in the peak, and you want to eyeball straight up and down, okay? And then you want to come like this, and I'm right in the light. I cannot, the sun is shining on my phone, so it's making it difficult. You want to eyeball right down the center and on both sides here to make sure that this looks good. And then you want to do the same thing over here. You want to start here, and you want to kind of close that gap with your mind's eye, checking both sides and looking down your center. If anyone has a good eye, then they can tell that I am just a little bit off on this one right here. Not bad, it's still acceptable, but it is just a little bit. That is normal. Every now and then you will get one off. If you get it off, especially like if I got this one off, then I have to be aware of that as I'm building these other ones, because I don't want to build these to this one. I want to try to like put a level across or something like that. Get them pretty close. You also, as you're building, you want to eyeball. You want to sight down here, sight down this side, and then you want to turn back around here and sight down both sides, running your eye down and across on both sides. You want to do that in several places. And if you have anybody working with you, every person that's working with you needs to be looking at that. No matter who's there, everyone needs to know you've got levels in your hand. You're constantly checking stuff with level. This should all be level this way, at least within reason. You should be constantly eyeballing, checking, it's typical to not get these absolutely perfect, but you want to set them as close as you can, with the understanding that once you weld them, sometimes they do draw just a little one way or the other. And that's what happened to this one right here, is when I welded it, I had a bit of a gap in this corner right here, and I had a gap right here on the other one. You can tell this one were good and tight, okay? But this one, I had a gap in here. So if I would have ground that bevel that we were talking about, and you can see I got a gap here, okay? So if I would have ground that bevel right there, the pull would have been worse. So what it did was, the majority of the gap was up here, and it pulled it inward, pulled it that way. It wasn't bad, it's still within reason, but if I wouldn't have been careful, and I would have already had that ground, that would have been that much more heat, and it probably would have drawn just a little bit more than that. So let's climb over here. Guys, y'all throw it in the comments if y'all have any questions here, or anything you want to talk about, or anything you think I've missed, anything you want to hear. Okay, so be sure and get a good sufficient weld here. That's practical. You definitely want to make sure you've got a good root and then a good 70-18. Please, please, please weld this out with 70-18. And also, please put your root in with 60-10, okay? Not 60-11. I know a lot of people, they think that 60-11 is just as good as 60-10. It is just as good as 60-10 when it's used for its correct application. And we'll talk about more. I will use 60-11 on this job. It has a proper application for certain things. But for rooting, it does not have the same penetration. So using a good 60-10 and using the correct procedure, you're going to get a much better penetration, okay? So the other thing I want to talk about is right here. This spot, I want to try to get this to focus well. This spot right here in a weld, okay? This is where a building fails. This is where I've seen trusses fail in the past, is right here or up on the other side of the peak. And we'll show you some more welds here in just a little bit. I'll show you some pictures, okay? But this peak right here will fail if you aren't very careful. So what I like to do is I like to build this edge up on top. I'll take and weld over top, and then I'll bring my weld all the way up, tie in, and then I'll go one more time over top. And that brings this above flush and make sure that you don't have a divot, because you can see here when we tack this together, we got a little bit of a divot. What that does is it creates a stress point right there. You have a stress point. So when you pick this truss up, if it failed, the fail is going to start right there in that little bit of a divot. So by completely eradicating that divot and making sure that you're above flush and that you are fully filled, you significantly lower your chances of having any issues right there. You also want to make sure you don't have any undercut or anything like that, because undercut can also cause a stress point. Okay, so this is kind of what it's going to look like, and I've showed you a little bit before already, but once you get fully welded, it is very important to go ahead and weld this with 7018, and this with 7018, and this with 7018. Once you've welded all of this, you don't have to weld this bottom side with 7018 because you've already got more weld than the amount of actual metal that you're holding on. So if you weld all of this, this is the easier stuff to weld. Then this bottom side, you can just throw some quick 6010 on there, or 6011 even would be fine, just to go ahead and close that gap up. With that being said, it's not very difficult once you've already welded all of that to just stick that rod in there and throw some 7018 on there. Okay, so whatever you got handy, you'd be fine. Just make sure that no matter what, you get 7018 here, 7018 here, and 7018 here. Now, a lot of people will tell me, okay, well, why is it not good enough to just put one here and here? Okay, well, if you think about this, that's resisting shift this way, okay? But you're not resisting any shift this way. A weld has this is 7018, meaning it has 70,000 pounds of tensile strength. That tensile strength is tested with a direct upward pull, okay? When you have a lateral pull or a shift like that, all you have to do is tack something and try picking up on it versus bending over on it. It's got almost no strength bending over on it. Part of it is because of leverage, and part of it is because there's just almost no meat in that direction. So this weld right here resists that lateral pull. It gives you a different load of strength. It gives you some more strength. And you also want to make sure you got some 7018 back here, and that's going to help resist that as well. One thing you have to think about with these buildings is the taller a building gets, the more wind it's going to get. Every building moves nonstop. It doesn't matter what building you're talking about. Every single building moves all the time. Okay, so you have to build them. That's why you have to weld them out with 7018. Doesn't mean every single part of it has to be welded with 7018, but your structural portions, everything having to do with these trusses. Now, there's different types of buildings, and I understand that. This is a pole barn style building. This is how we're starting, is with a pole barn, okay? Your structural part of a metal frame building needs to be welded with 7018, absolutely. So if somebody's building a building for you, make sure they're using 7018 for their structure. If you're building that building, make sure that you're using 7018 for that structure, okay? Make sure you're getting 7018 in all of these places. All right, guys, I said that I was going to give you a tip that's going to help you to get through this. Now, I am going to try to throw some other pictures in here before the video's over of some other little tips here and there. That's going to be right at the tail end, so stay tuned for that. It's going to be here in just a second. But first, I want to give you that tip that I was going to leave you with. Okay, so if you are building this building right here and you're left, let's say you cut this truss out and you feel like you did a good job, but when you lay this peak out, you're left with a dilemma, okay? And that is that you either got to make this line up nice and tight, this seam right here, and I'm talking about your very first truss, okay? You've either got to make this seam perfectly straight, or you've got to have the width of your building exact, okay? I'm talking about within a couple inches. All right, I'll give you the quick example. This building, the plan with a 412 pitch, the plan was to have a 40-foot wide building to the very outside edge, okay? Once we got everything cut, it ended up being about an inch under 40 foot to be exactly square, okay? So you're left with a dilemma. Do you stretch this open just a little bit? That would be a 1/2 inch on this side and a 1/2 inch on that side, which if you don't know is not very much at all when it comes to a building, okay? Do you stretch this open and end up with a little bit of a gap and go ahead and get your building to your 40 foot? Or do you close this up, okay? Whenever possible, whenever it's allowed, you always want to close this up and have this gap as tight as possible. And here's why. It's kind of like what we were talking about with the gap, okay? The more gap you have, the more drawing you're going to have and the more unpredictable it is. And the reason is because essentially you're allowing a thicker portion to be molten metal. Molten metal draws somewhat unpredictably, okay? So when you have a tiny, tiny place right here and you have some of this touching, then that's going to, your molten metal is going to help, it's going to make it draw one way or the other, okay? If you have more molten metal, then that's more unpredictability, okay? That's number one, okay? That's for your very first truss. As you come up, obviously the rest of the trusses have to match, regardless of whether there's a gap or not. You have to make all your other trusses match, okay? And that's why you want to try to do the best you can to do a good job. And you see, we did come out pretty good. We got that 1/2 inch off. I had somebody else cut these for me. But a 1/2 inch off, that's really good, because a lot of times when you cut these beams with a saw, it is hard to get that dead perfect. You either know or you don't know how difficult that can be to get that dead perfect. Okay, so as you're coming up, let's say that you do meet one like this one right here that had a little bit of a gap, or maybe more of an unacceptable gap, okay? Because a little gap is fine, but let's say it's getting into that unacceptable range. Like I've seen one that I worked with, it was a 3/8 of an inch gap down here. It was perfect down up here, but it was 3/8 of an inch down here. That's enough that you're definitely going to draw, okay? Well, here's the best tip that I can give you. If you can get a 3/8 chunk of steel and tack that in there, if you can have some kind of unmovable piece of steel, and I know that you won't be able to root past that 3/8 inch steel, but if we're only talking a little block, if you can get that 3/8 of an inch thick steel, or however thick it is, and block it in there to where that will not push or pull one way, you're going to have a significant, because most likely it's going to try to pull. It's going to try to draw in as you're welding. It's not going to flex out that way, okay? So by putting that in there, you're resisting the ability to draw in. And if you had the same 3/8 gap on both sides here, then you would put a little something there and a little something there. I'm not talking about a lot, because you still want to get a root in there and you still want to get a good solid weld. And if you have something that bad that you do have that 3/8 gap in here, then you probably do want to go ahead and reinforce that underneath weld, that root. Even if you do a good job rooting it, you probably want to go ahead and get something underneath there just to be sure that you're tied in well. But by putting that little piece in there, it's going to save you so much. Okay guys, stay tuned for the very last minute pictures that I think is going to help you a lot in some of this and in the structural strength of your building.